All right, folks, we have another example of graphing rational functions with only horizontal asymptotes, no slant asymptotes in these. And the example we're going to do right now is number 55 off of your homework if you're playing along at home. So this is going to be number 55. It's example number 55. And the function looks like this. It says r of x is equal to x squared minus 2x plus 1 divided by x squared, x cubed minus 3x squared. Try to zoom in just a little bit here. And this is a cubic right here, x cubed. So the first thing we always do when we're dealing with a rational function like this is we want to factor the numerator and factor the denominator. So let's go ahead and do that now. R of x is equal to x minus 1 and x minus 1. So that's going to give me a positive 1. If I add them together, I get the negative 2, which is the coefficient here, which works out nicely. So the denominator looks like this. I have x squared. I can factor out of both of these. And that's going to leave me with x minus 3, just like that. So if I look at these here, I notice a couple of things. One is that I have x minus 1 shows up 2 different times. That's called multiplicity. So I know that I have an even multiplicity here at a 0 of x equals 1. And if I look in the denominator, I also have multiplicity on this little guy right here. And this is the type of problem that gets a lot of students because it's not really obvious that there's multiplicity here. But this is indeed the 0 of your denominator, which is going to translate into a vertical asymptote. And because it also has even multiplicity, it shows up twice, we're going to bounce when we look at our information wave at 0 and at positive 1. So let's go ahead and go through that now, and let's figure out what our zeros are, and let's figure out what our vertical asymptotes are going to look like. So zeros. I'm going to have zeros at x minus 1 equals 0, which is going to leave me with x equals 1. So I have a 0 at 1. And this 0 has even multiplicity. So when it has even multiplicity, what does that mean? Well, that means we're going to bounce on that information wave. So that's my 0 right there. And we can now go ahead and see what we can tackle with these vertical asymptotes. So I take these two factors down here. I have x squared equals 0, and I have x minus 3 equals 0. So this means that I have x equal to 0, and I have x equals positive 3. And this is where my vertical asymptotes are going to be. So I know that I have multiplicity with this 0, with this asymptote over here, so I have to make a quick little note down at the bottom. Then I'm going to bounce because the multiplicity is even. All right, so I have my zeros, I have my vertical asymptotes. I can now figure out what my horizontal asymptote is going to look like. And if I notice in my fully expanded form, the standard form of this rational function, I have a degree of 2 in the numerator and a degree of 3 in the denominator. Any time that the degree of the denominator is greater than the degree of the numerator, so anytime the exponent is larger in the denominator than it is in the numerator, you're going to have a horizontal asymptote at y equals 0. So horizontal asymptote at y equals 0. And that's any time that the degree of the denominator is larger than the degree of the numerator. If you think about what happens as x gets bigger and bigger and bigger as it approaches infinity, right? The limit as my function r of x approaches infinity, or as x approaches infinity within my function, I have to think about the denominator gets much, much, much larger than the numerator, effectively making the entire fraction 0. And that's how I wound up with this horizontal asymptote at y equals 0. So let's take a look and figure out what our y-intercept is going to be here. And the y-intercept is a little bit interesting. So y-intercept is when I evaluate my function r at 0. And if we notice, when I evaluate this function r at 0, because I have 0 here and 0 here, my denominator goes to 0, which makes the entire function undefined. Well, what does that mean as far as my y-intercept? Well, it means there is no y-intercept, so it's not applicable here. And why does that happen? What else is happening at x equals 0 where that y-intercept usually lives? Well, I have a vertical asymptote there. So I can never cross the y-axis. And that's why all of this sort of kind of works together with this y-intercept and these asymptotes here. All right, so we have our zeros, we have our vertical asymptotes, we have our horizontal asymptote, and we have our non-existent y-intercept. So we're ready to make our information wave. So start off the information wave the same way we always start off our information waves, by creating a little number line right along the top here. So make my number line right there. And I'm going to put my 0 right in the middle just so I can have a little reference point telling me where I'm located on this line. All right, so let's take a look at our zeros. I have a 0 at positive 1. So I'm going to go ahead and get my blue pen out. And I'm going to make a little circle at x equals 1. Right there. And I'm going to label it just so I know where it is. Now, I also have two vertical asymptotes, one at 3 and one at 0. So I'm going to put a little x right at 0. And that one doesn't have to be labeled because I know it's right at the center because I had a little black dot there. So this is my asymptote that's going to have multiplicity. So I have to bounce when I get to this one here. And then I also have another vertical asymptote at x equals positive 3. So that's positive 3 right there. All right, so now that we have our zeros and our vertical asymptotes laid out on there, we can go ahead and actually generate our information wave. So if I look at this here, I look at the leading coefficients of my numerator and my denominator. They're both indeed positive. And when those two are positive, that means I start up in the top right-hand corner. And at x equals 3, I have an asymptote. But it is not the asymptote with multiplicity, so I'm just going to rock right on through there. I cross up, and I have multiplicity at this 0. So that means that instead of crossing, I'm just going to bounce right off the bottom there. And finally, I come right up to this final asymptote, and that one also has a bounce because there is even multiplicity, so I'm going to bounce on downward. So what does this tell us? Well, this is what it tells us right here. It says that my graph is going to be negative almost the entire way through. Even when I touch that 0, I still stay negative until I wind up on the other side of my asymptote. So remember, we cannot cross asymptotes, but we can get mighty close to them. So, all right, let's go ahead and draw out our Cartesian coordinate down below, and I'll try to line it up just ever so slightly. There's that. All right, so take this and make my axes. It's that one. And There's that one. And I can go ahead and lay my zeros on there, or my 1, 0, which is at positive 1. And be sure and label all of these points here. I also have a vertical asymptote at x equals 3 and one at x equals 0. So I'm going to try and line these up here just a little bit. You don't have to line them up, so sometimes it helps us see things a little bit clearer. So there is my vertical asymptote number 1, and here comes vertical asymptote number 2. There's vertical asymptote number 2. And I'm going to throw in a horizontal asymptote also, and that horizontal asymptote was located at y equals 0, if we remember here. Y equals 0. That was my horizontal asymptote. So I'm just going to draw it right below it, just so we can see it. It really should be on the line, but in order for us to see these asymptotes, we sometimes offset them just a little bit so that we can see clearly. And I'm going to take it out nice and far so we can have some place to come in on. All right. So there's our horizontal asymptote. There's our 2 vertical asymptotes, and we should label these vertical asymptotes with their positions. And this one here was at positive 3. And this horizontal asymptote was at y equals 0, just like that. And now we can start to draw our graph. So I know that I'm always going to come right in along that horizontal asymptote. So I can go ahead and draw my 2 pigtails right now. And this one's going to be just slightly below. This one here is going to come slightly above. Right there. So now I have my 2 little pigtails. And I can follow them wherever they take me. So I'm going to drive this way. And then once I come to this asymptote at 3, I notice that anytime I'm on the right-hand side, well, I have to go positive. There's that. And anytime I'm on the left-hand side of this asymptote, I have to be totally negative. So I'm going to come in from down below, and I'm going to end up down below. And the path I'm going to take is going to just barely kiss that 0 right there. And there's that portion of the graph. And now we can take this end over here and we say, okay, we're going to be negative the whole way. Even when I come up to that asymptote, I have to make the decision to go up or down, and I'm going to go down because my info wave tells me that I have to be negative the whole time. And that's the entire graph right there.